Hi, I'm WeatherWorks meteorologist Joe Martucci. It is Monday and we're here for another edition of our Monday Mailbag. And for this week, we're getting our question from Facebook, from Nick A. So thank you so much, Nick, for the question. We really appreciate it, and we're going to answer your question here, which is, can you give me some insight into how to better track tornadoes and the weather prior to them touching the ground? What we're going to look at first is our radar. On the top, probably something you've seen before, regular radar product. We have our greens, our yellows, our reds for our really heavy rain. And what we're going to look for is something called a hook echo. And we're looking right over here. You can see the hook extend from pretty much right where the cell is down to a little hook. And this is actually around Tuscaloosa, Alabama. So when you have that hook echo, that usually means a tornado is either developing or could even be on the ground. Now on the bottom is probably something you haven't seen before, at least if you're not a meteorologist. This is our base reflectivity product, which shows how fast objects, in this case rain or debris, are moving to and from the radar. So when we have greens, that means it's moving to the radar. If you have reds, they're moving away from the radar. What you want to see here, again, where that hook is the greens meeting the reds. When they come together, that is a tornado vortex signature. That means a tornado is almost about to occur. Again, could be on the ground, it could be developing. Both of these are the same radar time, but they're different products. So that's what we're looking at in terms of when the tornado is close to or has developed. Now, beforehand, when we're forecasting a tornado, a few things we're looking for. One would be instability, or CAPE. That's convective available potential energy. You may have heard of that before. That's a measure of how unstable the area is. The higher the CAPE, the more likely there are for thunderstorms and tornadoes. Then we're looking for warm and moist low levels. So a couple thousand feet above our heads, we want that to be warm and we want that to be juicy so we can get a tornado. Then we're going to want turning winds with height. That's directional shear. So we have in our example here, if winds start out from the south at the surface, but 5,000 feet above our heads, it's from the west, that's directional shear. That helps to turn the atmosphere, that helps to give us our tornado, since that is a rotating cloud after all. And then we need a trigger, whether it's a cold front, a warm front, something in the upper levels of the atmosphere. We need that in order to give us our tornado-like atmosphere. So thank you, Nick, for the question. We really appreciate it. You can submit your questions to us on our social media pages. We're Facebook, Twitter, and Snapchat at WeatherWorks, or on Instagram at WeatherWorks LLC.